Welcome to Discovering the Magic of Number Theory. In the last session, we talked about prime factorization, and relatively prime numbers. This session is going to be broken up into two parts. We're going to have greatest common factor and least common multiple. I wanted to put it together, but then I realized that it's going to take a little time, and so I didn't want to make the video too long for you. So we're going to do, this session is going to be greatest common factor. Next session is going to be least common multiple. So go ahead and have your notes ready, and we're going to take some notes on greatest common factor today. So this graphic is on greatest common factor. I wanted you to look real quick. This is an infographic that I've made, and part of your quest is going to be to make an infographic, and so this is an example of an infographic. But we're going to go over the first part, greatest common factor, today. Greatest common factor of two or more numbers can be found in many different ways. The GCF is useful for simplifying and comparing fractions and solving and simplifying equations. But most importantly, these are usually found when you're taking the academic team governor's cup test. These are usually found in questions like 1 through 5. They're what's considered to be the easy questions. And the reason why I want to go over this is not because they're hard to do. They're not, but sometimes they take time. And that time that you take away from by doing this and doing it like the long way to make sure you get it right, that's less time at the end when you really need that extra time to solve those harder questions on a governor's cup test. So there are three ways listed here on finding greatest common factor. Okay, you've got the listing the factors way, the factors trees way, and the ladder method way. Now, listing the factors and factor trees are the ones I'm most comfortable with. The ladder method was kind of new to me, but then when I dug into it, I was like, okay, this actually could be the quickest way when we're dealing with large numbers. Now, we're dealing currently with 12 and 18. So let's look and see, like, when we get to the higher numbers, like what way would work. So the first way is listing the factors. You just simply list the factors. When I was a kid, I did it like a rainbow, like 12 times, or 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and kind of did it that way. Same thing, 1 times 18, 2 times 9, 3 times 6. Once they're all listed, then you can easily see what the greatest common factor is, okay? Another way of doing it is factor trees. We talked about that in the last session, how to do a factor tree. I feel like doing a factor tree makes it easier than listing this out, especially if we're dealing with numbers in the hundreds or even the thousands. Could you imagine making a list with hundreds and thousands of every single one of the factors? So sometimes factor tree could be easy. So again, 12, 2 times 6, 6 breaks down to 2 times 3. 18 breaks down into 2 times 9, 9 breaks down into 2 times 3, and then you see what they have in common. They have a 2 in common, and they have 1 3 in common. So it's only the things that they have in common. 2 times 3 is 6. That's the GCF. Now, but let me show you the ladder method. The ladder method is very similar to the factor tree. However, you're only writing the numbers down one time. So let's look here. So we draw a little, like upside down ladder, I guess, or maybe stairs. It kind of looks like stairs going down, doesn't it? You list your numbers 12 and 18. What goes into both 12 and 18? Well, immediately I see 2. So 2 goes into 12. 2 times 6 is 12, so I'm going to write the 6 here. 2 times 9 is 18, so I'm going to write the 9 here. We're down to the next stair, or the next part of the ladder. 6 and 9. Does anything go into both 6 and 9? Yes, 3. 3 goes into 6 2 times, and 3 goes into 9 3 times. And then now we're at the bottom of the ladder, or the stairs, 2 and 3. What goes into both 2 and 3? Nothing besides 1. So that's it, and we have 2 times 3. This way right here kind of makes a lot of sense to me. So what I want you to do right now, pause the video, take the notes, focus on the one that you think might work the best for you, especially in a Governor's Cup competition setting. And then we're going to come back and we're going to do a couple of practice problems together so that you can work through those, especially with those larger numbers, or when you have 3 numbers that you're finding the GCF of. Okay, so here's a couple of practice problems we're going to do. I went ahead and went up to the higher level. So pulled this one up, 34 and 68, and I almost skipped over it because I was like, oh, that one's too simple. However, what I want you to think about immediately, like when you're looking at those, before you start doing a prime factorization factor tree, anything like that, immediately start looking, does your first number go into your second number? Now, honestly, on Governor's Cup, like the tests, probably not, because it's going to take a little bit longer. However, in a quick recall, that was hard to say, setting, it could be. So think about, does that smaller number go into that larger number? And in this case, it's yes. And so I would have been quick to do a lot of the prime factorization and get down to be like, oh my goodness, I just wasted time. So think about that first. But on this one right here, 40 does not go into 72. So now we have to find their factors. Now, like I said, I'm more comfortable with doing the factor tree. So I'm going to try out the ladder method just because I want to see, does it work and does it work really quickly? So we'll draw this. Am I doing it right? Let me go back to my thing. Yep, draw this. We've got 72. I guess I need to do this, don't I? And we've got 40. And so we've got to see what goes into it. And honestly, for me, if it's an even number, I'm going to immediately put 2 because you're immediately cutting your work in half just by doing that. And it makes the easiest sense. So 2 times 36 is 72. 2 times 20 is 40. Okay. Now we're going to go down to the next part of the ladder. Again, it's even. So I'm going to put another 2 here. Cut it in half again. Now we're dealing with 18. 2 times 18 is 36. 2 times 10 is 40. And then let's go down to the next part of the ladder. Again, it's even. So we're going to put a 2 here. That's beautiful. 2 times 9 is 18. 2 times 5 is 10. And now we're getting into something that, okay, 9 and 5 have nothing in common other than 1. So we're going to do 2 times 2 times 2. And that's 8. Gosh, that to me saved a lot of time. So let's do another one. Okay, again, 60 doesn't go into 90. However, we know 10 does. If 10 does 20? 20 does not. What about 30? 30 does. And I think 30 is the biggest one there. So those are, like, some of them are going to be super easy, but some of them are not. Like this one right here. That one's not as easy for me. 97 is a little bit tougher. Well, does 48 go into 97? No, because 48 times 2 is 96. No even numbers are going to go into it. So then we got to see, like, other than 3, there's not really. So 9 times, or excuse me, use your, again, your, like we talked about in the last session, 9 plus 7 is 16, and 3 doesn't go into 16. So this is a fair chance to say that 1 is the greatest common factor of those. Okay. 7 and 19. 7's prime, 19's also prime. If they're both prime numbers, then you know that their GCF is going to be that one. Okay. Let's look at the next one. 9 and 90. Well, 9 goes into 90. Let's find one that's a little bit harder. Oh, I love this one. 91, 75, and 84. Do I want to do a prime factor tree for every single one of these? It just doesn't, it's not gonna. Let's see if the ladder works for this. The ladder worked for the one that I could have done it easy on. All right, so let's try it. Again, your ladder does not have to be beautiful like mine. This is beautiful work. 91, 75, 84. And let's see. I'm tempted to think maybe, like, I'm not sure. Let's look and see. The first thing I would do is I would check to see if 3 goes into it. 9 plus 1 is 10. 3 is not going to go into it. So 3 isn't going to work. Okay. This is odd. So 4 is not going to work. 2, 4, all your even numbers is not going to work. 5 is going to only go into 75. 7. 7's going to go into 84, but is 7 going to go into 75? 7 times 11 is 77, so 7's not going to go into it. So on this particular one, I almost think it's going to be 1. So let's check and see. Yeah. All right, let's do one more problem. Okay, well, that one's an easy one. Don't do that one. 2. 4. Does 4 go into 40? Yes. Does 4 go into 52? Yes, it does. So 4 is going to be it. Give me a hard one. Oh, my goodness. 37, 38. Right here. This 37, 38, that's telling me it's 1. That one's going to be 2. Come on, IXL. Give me something harder. Okay, this one will work. This one's good, but again, 4, you gotta see if 4 goes into all of these. 4 goes into 52, it goes into 32, and it goes into 100, so it's 4. Alright, so hopefully those will be some of the hardest ones that you get, but hopefully this helped you. Have a great rest of your day, and come back for the one on least common multiple.